Hello everybody, welcome to this class. And in today's class, we're going to learn about arrays. So the definition of array is a collection of variables of the same type. So up to this point, we learn about basic types, so integer, strings, boolean, char, and then strings, and about class and object. So an array is a collection of any type that we can use, we can have. So uh, array is considered like the most basic data structure because it's where we go beyond just have one single variable. We can store a collection of them. So is that why uh, some define array as a data type, not actually a data structure, but there is definition that array is a data structure. So is I think it's a fascinating one because it's very simple and very powerful because most of the data structure you're gonna learn in the future, like linked list, trees, stack, heap, and queue, can be simulated and implemented in an array. So is that why it's very important to understand it and master arrays. Some properties of the array. One note here that those properties are for the classic definition of array. Some language, for example, Python and JavaScript, they do have some variance and they don't follow exactly those, but most of the language and literature, when we talk about arrays, those are the definition. So the first one is that all elements are of the same type. So when we define the type of an array, that means that all elements in that array are of the specific same type. The size of an array or length, as we call, is static. So once we define a size of an array, we cannot change it. We cannot shrink or enlarge the length or the size of an array. Of course, if you have the need, we can recreate a new array bigger and smaller and then move the data that we may need. So that doesn't prevent us to use an array in situation where the data can grow. Of course, we're gonna have better data structure to deal with those situations, but array, like I said, is the most basic one. And as an array is a collection of variables, we must have a way to access those variables. And the way that array allows is by using index. So an array is a collection of variables that we use an index to access each one of those variables. And those indexes are zero base. That means the first element in the array, the index is zero, and the last element of the array is the length of the array minus 1. For example, if we have an array with length 10, the first element is 0, the second element is 1, and so on. And the last element is 9, that is 10 minus 1. Okay? So this is how initially array were defined and created. So every language that I know follow this idea. There is some variance in here and there. For example, Pascal, they have an array that we could define the index of the array. So you could doesn't need to be 0 to something. You could define different ranges. And the size of an array, or the length as we call, is stored in a property called length. So every array, there is a property called length that store the size of the length of that array. And it's a dynamic type. So like a class and object, array are stored in the heap, not in the stack. So we're gonna see some exercise and then we're gonna understand this better. So just to make clear, like if you use like a basic type like integer or char, boolean, that variable is stored in the stack. That means it's part of the same memory segment that the code is running. Dynamic types, they are like object or class, they are instantiating, creating the heap. The same for an array. So arrays is a class that the data and everything else is stored in the heap. The declaration of an array is we have to provide a type and then square brackets and then the name of the array. So whatever the type of the array we put here, like int, string, or customer, product, or whatever we need to, and then we give a name that is any identifier. The initialization of an array, we provide the name, of course, and then we use the equal sign, new, the type of the array, the same one that I use to define the array, and then the length, how many elements we want there. So this is like similar of instantiate like object. So imagine this is the constructor, and instead of the parentheses with the possible attributes, we put the length. So just to do some mental exercise here and using our imagination to see how this would work, let's imagine something like this. I will draw something here, like simulate our computer memory. Down below, we have the stack. That is where our program is running, like in the memory. And here is the heap. And usually what happens is they grow in the same direction. So I think you all should know about this already, but if not, just a quick explanation here. So this is the static part. So this is where we load our code and our code is executed. And this is where the dynamic variable I create. So if in our code we type something, imagine that here will be our problem. Okay, so in somewhere we're gonna have like the main method. Let me increase the size here. And we'll say something like declare an array of integers. So int, open and close square bracket like here, and then we can give a name. Let's call numbers. So up to this point, we just created a reference in our memory. Let's give something like this here, a reference called numbers. That up to this point is no, there is nothing there. Okay, so there is no space allocated yet. We could, in the same line or in the next line, we could initialize it. You could say numbers will receive new int array of 10 elements, and then close. That means that in this point, let me do a quick copy and paste here. You go here. In this point, an array, oops, sorry. An array will be allocated in the heap. And then this guy here will be point to this array. Okay, and remember that there is like a separation here from the heap or from the stack and from the heap. So now how we use the array? Imagine that, oh, and one very important thing, when we initialize the array, all the elements are initialized with the default value of the type of the array. So if this array is type of int, in Java, the default value for int is 0. So what happened is this array will be filled, oh, I need a brush. Will be all filled with zeros. So we're gonna have like 0, oops, what 0 is that? 0, 0. If our array is Boolean, I think the default is false, so it will be all false. If it's in object type, class will be null, will have no value, so we need to initialize before we use it. And imagine that we want to assign a value to an array. So it's something very simple. We go to our code and we use our array identifier, like in this case, numbers. We pick up an index like 5, and we can say 5 will receive 10. So that means now our array called numbers in the index. Oops, wait, I made a mistake here. Let me fix. I have to delete the entire line. Sorry about that. Quick fix. I said 5, no? So in this moment, these numbers, let me put in the index 5, pay attention that 5 is a fixed element. 1, 2, 3, 4, 5, 6, because the first one is 0. So in this element, whatever is there is going to be replaced with the new value. That now is 10. Okay? What if I want to add a value to the last element of the array? So I can use some, if I don't, here I can look and say, oh, it's 9. But every time I want to reference the last element of array, there is a trick. We can say, okay, I put like the array numbers. The position I use will be, let me just increase this. So will be the same array numbers dot length of dot minus 1 will receive 5. So this is interesting because this formula here, oops, I need this. Where is my pointer? Come on, Jose, what are you doing? So this formula here, in this case, is what is the length of the array? 10 minus 1 is 9. So what is happening is we're gonna get this. So this is just a shortcut that help us without knowing the size of the array. Imagine that we have a method that only receives the array. How we can make a reference to the last element. So we're gonna have, in this case, the last element will receive 5. So very interesting, no? It's a very clean and easy to understand concept. And the good thing is open the door for very interesting like question. Is data structure that is used a lot in interview question, because basically we can do very simple algorithm and very advanced ones in array. So we could use array to basically train most of the algorithm logic that you want to learn. That's why it's important to learn array. So this class is just like in the initial learn about it. What I'll do now is I move to our code, because I know that we love C code. It's important to understand this theory, but now let's look at the code running, and then we can have a better understanding. So in here, like I will share in the description of the video a GitHub repository with all this code. So there is some other content there from Java codes, like from the base, and we are here focused on the array class. So that definition is here as a commentary. And then there is a link I put here for the W3 W3 Schools that has very nice documentation. And you can see there is not much because it's very simple. What will you do next is do a lot of exercise. You're going to learn some more theory. And then down below here, there is a list of 27 questions that ideally you should train on it. And let's go back. So what you do now is I will put a breakpoint right here. And then we can follow this code, try to understand some of the basics. So I'm gonna just reaffirm what I showed already, just make it easier for you to assimilate and retain this knowledge. So let me right click and then run in debug mode. So this is the local variable spectrum. So it's like we are looking to the memory. And so in this point, we are doing just one line. We are declare the array, giving identifier or variable name, and we are already defined the values for this array. For this array, we say, oh, I want a new array. We use this bracket here, open bracket, and then close bracket, and then we put all the values there. 1 to 9. So when we execute this line, we will see in the memory that we have an array called numbers. It's showing here like the how many elements there, int 9. So this is what was using in the declaration, and all the elements there. Do you see the first index is 0, the last index is 8 in this case, because there is only 9 elements there, not 10 like the one I showed before. And in the next line, you're going to print a format string showing length and then the numbers dot length. So in the next line, we should see length equals to 9. Just to show some operation that we can do in an array, there is a method called print an array that we can give a label and the array. So this method is down below here. So if I do a step into, we're going to see the logic of that array. It's just to show some operation that we can do in an array. So in this case, what are you doing? Oh, if there is a label, let's print that label. And then we're going to put like dots, spacing, open square brackets, and then the label. So when you execute this line, pay attention down below here, you'll see exactly the output of that, numbers. And now there is a comment here, help us understand. Print inline, that means we are keeping the same line, not adding new lines every element. All elements but the last one, followed by a comma and space, because the idea here is for we have a for looping, start with 0, going all the way until the second last element of the array, because I say while I is smaller than array.length minus 1. If I just put smaller than array.length, we will go all the way to the last, because remember the length is 1 unit greater than the last index. In this case, you understand why we want to print, pay attention here, every value of the array followed by a comma. So we put 1, 2, 3. So that means we cannot go all the way to the last element. Otherwise, we're going to have an extra comma in the end. So we will print until 8. We finish this loop. And then now we print the last element of the array. Is that why I show you that example? And after that, we print a new line with the close bracket and the new line. And now we have the array there. Okay, just an example there, how to access a position of the array. So we are showing numbers at index 5 is equals to numbers 5. I guess you know about this. Printf is just a format. So there is a string interpolation here. This is a string that I want to be exact like that. And this is what is going to be replaced by this. So it will be numbers in position 5. And this is just a new line. Yeah, okay. So what you do is we print numbers at the index 5 is equal to 6. If we pay attention here, we can see that. See, index 5, the value is 6. Now we are setting a value for a new element. So numbers 5 receive 10. Pay attention here that should change it from 6 to 10. And we will print that same position again, just to make sure that it's working. And we will print the entire array again. I'm not going to step in just to see the full result. We can see that that position was changed to 10. I will show an example now where we're going to initialize a new array. So this array was already like a constant. Not a constant, but they already have the initial values. As you can see, it was not a constant because we could change it. But here, what you do is you're going to create a new array. And like I said, when we create a new array, I'm using the same reference. So the other one is gone, and we're going to have a new one that is an array with 5 positions of integers. So we can see here. Pay attention now that every position has 0 because it's the default value for an integer. And I will I will set each position like to 10, 20, 30, 40, 50. So I will see what is going on in here. And I use the same function, same routine we had to print the array. So now I'm printing numbers again. Okay, so yeah, that was the basic understanding of the array. We will have another class right after this one about some basic operation. So stay tuned for the next class.